Okay, so this video is going to walk you through the sort of procedure that you're going to be using to solve problems using Newton's second law of motion. I want to emphasize that this procedure I'm about to go over, this is going to be how you solve 95% of the problems that we're going to do over the next couple of months. So if you actually really understand what I say in this video, the rest of the course is details practically. So make sure that you internalize this procedure. And if you're confused about how to solve the problems over the coming weeks, come back to this procedure and make sure that you're going through it and thinking through it step by step. And this is how you solve all the problems in the class, okay? So how do you do it? Step one, draw a diagram. And in particular, we want a diagram that shows all the forces that are acting on a particular object. Because remember, in F equals ma, F represents the sum of all the forces acting on a particular object. So the first thing you need to do is list off what are all the forces acting on this object, which direction do they point in, and sort of wrap your head around what that looks like. This is referred to as a free body diagram. So that's the name we'll commonly be using. Sometimes people abbreviate it as FBD, free body diagram. Okay, we'll come back to how to draw a free body diagram momentarily. Step two of the procedure, once you have your free body diagram, you want to break all of the forces into their components. Using the procedure that we developed a little while ago in the vector section, you draw a right triangle for each vector, break it into its x and y components, and now you have each force an x component and a y component. Then the next thing you do is sum all of the x components of the forces, and you separately sum all of the y components of the forces. Which is really what I'm doing here, you'll notice, is just going over the vector addition process again. Remember, in vector addition, you break everything into components, add all the x components, add all the y components, same exact thing. I'm really just re-explaining the vector addition process here. And then lastly, the final punchline is that the sum of all the x components equals m times the x component of acceleration, and the sum of all the y components equals m times the y component of acceleration. Okay, so in other words, one thing I want to be very clear about, when we solve F equals ma, 99.9% of the time, we're actually solving a separate F equals ma problem for x direction and a separate one for y direction. If you had a three-dimensional problem, you would solve a separate one for z direction. So really, when we say that F equals ma as a vector equation, what we really mean by this is two algebraic equations. The sum of the x components of force equals max, and the sum of the y components of force equals may. So that is the way we're going to break it down. So if you follow these steps, you will have a firm foundation on which you can actually build something. And that something you're going to be building is, over the coming weeks, we'll learn about many different kinds of forces and many different kinds of motion that the object can have, but it's always going to refer back to this same exact framework, and we're going to be going through those same steps to solve just about every problem, like I was saying. All right. So maybe I'll end this kind of procedural section here and do a separate video about how to draw free body diagrams and things like that, which is another important topic.